Okay, that's about the right amount of faffing around. So that is 5 past. So I guess we should get started. Did everyone get the 1 minute paper?
Keep
no. It's a big
keep
time.
them moving.
Okay, so we'll start with some Administrivia and foreign things. So first of all, this is CS410, Advanced Functional Programming. If you're expecting something else, you're in the wrong place, too late. And I'm Fred. It's nice to see you all. So I'm the official lecturer for this class, and I guess I'm the one that's going to do most of the work. That's not true. The demonstrators are going to do most of the work. So Sean is one of the demonstrators that's going to help you in the labs. George is another demonstrator who's not here today. He's in Berlin delivering a talk as we speak. And Connor is here for his sage wisdom.
Yes.
Because he likes it.
Yeah. Fred's the boss.
Right. So I'm not sure. I sent out a my place message and one again today. So I'm sorry if it was too many of them. And one of the things that it contained was that there's a Mattimos channel, which are all strongly encouraged to join. I mean, now that COVID is over, in quotes, but we can do this in person, of course, but it's still easier to do things on the Mattimos channel at 3 in the morning rather than trying to do something in person. So if you have any burning questions or anything, then I would strongly encourage you to join this channel. And we are very happy to talk to you there.
Yeah. Usual story, way better than email because it arrives not mixed up with everything else. And more of us are watching.
Yes. and yeah, if you don't feel too embarrassed, if you have a question, try to ask it in the channel rather than a direct message, because that means that you have a greater chance of getting a good answer, not just from me. Right, so I passed around these 1 minute papers, so please fill them in, even if you just fill in the bit at the top where you try to remember your name and possibly the date. And the reason I'm asking for this is firstly because it's nice to know what I said that didn't make any sense, so we can correct it. Although, of course, shout out, it's better if you shout now rather than write it on the piece of paper, but it's still better if you write it on the piece of paper and not saying anything at all.
So you're okay for questions through the point at all?
So no.
Okay.
Yes, I am. Yeah. Such as that one. Yeah. Yeah, please stop me if something doesn't make sense. That also applies to Sean O'Connor or anyone. Yeah, so also encourage heckling indeed. Right, so the other reason I just want to point this out, the 1 minute paper, I also use that to take attendance and enter that into the system. So even if you have no questions, please just fill in your name and hand it in. Right, so COVID, so we're here in person. Hopefully nothing bad will happen, but if you feel a bit anxious or anything, I have a big bag of masks here, which we can do because we're a small class. I wouldn't do this if there was 100 of you, but since there isn't, if you want a mask, take one, even if it's just for the train back or something, that's fine. If you do get COVID, whatever you do, please don't come and give it to us. Nothing's that important. And hopefully this Zoom thing will work, right? So if you, for some reason, can't attend in person, then just let me know and I'll share this link. Or it doesn't have to be COVID, but I mean, I think it's nicer for everyone if we can do this in person. It's nicer for me to not talk to an empty room, and it's hopefully nicer for you to be able to see me. But if for some reason you can't make it, then let me know, and you can join on the other side of this link instead.
And if physical presence is all too much for you, we can probably print out a black rectangle with your name on
it. Right, so the timetable, I think you know this already, but just to repeat it one more time. So Tuesday is the CS410 heavy day, where we have 2 labs and 1 lecture. We didn't have the lab today. I hope no one showed up. But in the future, we will have a lab in the morning, and we will have a lab directly after this. And we will still have that lab directly after this, just to get things ready.
Yes. Installing Agda is generally a 2-hour lab job. It's
yeah, but then hopefully we'll be done. Right, and then we have this lecture on Thursday mornings as well. So SW is Stenhouse Wing, I believe.
Yes.
That's up the hill. and through the maze, and then hopefully you'll find it.
Yeah, it's on Cathedral Street,
Oh,
over the road from the gym.
Maybe on first day I would budget an extra 5 minutes in order to find it, and I'll do that myself. Okay, assessment. Let's getting through all the fun stuff here. So the good news is that this is 100% coursework class, right? Which means that you don't need to worry about an exam in December, and you can focus on other things. The bad news is that this is 100% coursework class, which means that you will have to do some work throughout the semester. Right? I think this is the best way to actually learn, rather than just listening to me or Connor talking about things. You'll actually learn something by doing these courseworks. So there's 3 of them. They are worth 30, 30, and 40% each. And they are due in week 4, week 7, and week 12. So that's just the beginning of the assessment period. If these deadlines are a little bit too harsh for you, let me know sooner rather than later, and we can work something out. I mean, it's the deadlines are mostly for you so that you don't have it all hanging over you and then you never finish. Right? I mean, my real deadline is the exam board in January. So
it's not so much a deadline as an undeadline, right? You think you've escaped it, but it gets up and chases you.
So the first coursework is available in the GitHub repository, so you can get it now. And you can maybe start working on it after you install Agda this afternoon. And then I'll release the next one just when this one is due. So even if you don't finish this one quite on time, then I'll release, then I'll release this one, and so on. And the point is that you're supposed to come to the labs and do most of the coursework's in the labs. That's why you have so much lab time, so you can get some help and not get stuck.
so in the labs, it's only the coursework.
There's nothing else in the labs, yes. Right, okay, so we have this complicated way of submitting the coursework because it's more fun this way. So the main idea is that you make your own Git repository, and then you submit the coursework by pushing to this Git repository.
Right, can you insert the word private between R and repo?
Yeah.
Do not publish your solutions for everyone else.
Yeah, so make a private repo somewhere. I mean, GitHub, GitLab, Bitbucket, your own server, whatever you want. But make sure that I can actually get access to this and clone it. Then I would recommend that you add the class repository, which is public on GitHub, as a new remote. So do it this way rather than the other way around, so that you, by default, when you push to your thing rather than pushing to my thing, because that's not going to work, right? So if you don't know how you do this, then I'm just offloading this to Sean so he can help you in the lab. I'll also try to remember, but basically make a new remote so that you can pull the coursework from the class repository and you can push your solutions to your private repository. And then in theory, you don't have to do anything to submit. I'll just take whatever is, unless you told me you need a deadline extension, I'll just take whatever is there after the deadline. But in practice, I feel a bit more relaxed if you tell me that you're done and I know that you've done something. So I would appreciate if you could send me a quick message on that the most when you consider yourself done. But you don't have to do this. Just look at whatever you submitted after the deadline. Okay, and then I will go away and mark it and leave you some comments in the code, and either send you an email with these comments or maybe upload it to my place because we have a new moderation policy and it's all a bit much, but that's life. So I'll try to get it back to you within 1 week, maybe 2 weeks with this moderation policy. And that should give you your score and also hopefully some comments on what you've done.
Who's the moderator?
Bob.
Right.
So it's not impossible, but
Yes.
and then I would like you to talk through at least one of your courseworks with me. So we'll schedule an appointment, say, okay, I would like to discuss coursework 2. Then we find the time, and then we could do this in person or online if you want to. So we sit down and we just talk through your solutions. And if there's anything you found interesting or anything you didn't understand or anything you didn't even get started on and wanted to push or something like this. So officially, this is where I can tell the exam board that I know that you definitely done it yourself, right? But unofficially, it's because it gives us all a chance to explore it a little bit more. And it's not supposed to be a scary thing. It's not supposed to test you in any way. I mean, if you didn't quite understand how you're supposed to do it, then we just talk about it and it's fine, right? But it's just to make sure that you've actually done it yourself. So yeah, I'm very happy for you to talk to each other about the coursework, but of course you have to submit your own thing. You have to write your own thing. And this is the mechanism to make sure that you don't submit something you don't understand. But if, yeah, hints and even general discussions about COVID is perfectly fine. Okay, any questions so far? No? Okay, so that was all the admin stuff I could think of. Did I forget anything?
Sounds about right. Guess it's also worth saying that this is the kind of most research aligned class module, sorry, old terminology, in the whole of our undergraduate curriculum, which means hopefully you'll get quite a lot out of it if you put a lot into it. It is possible through persistence to score very high marks in this class, even when there isn't a no detriment policy due to COVID. The last year I taught this class, we just about managed assessments 1 and 2 of 4 that I was planning. The earlier ones are always easier because we haven't taught you as much yet. And then lockdown happened, no detriment kicked in, and I had to give a lot of really clever students marks in the 90s. It was dreadful. My conscience really struggled with that for almost a nanosecond. And of the 15 people taking CS 410 that year, 10 of them were the top 10 students in the year, and the other 5 were not far behind. And that wasn't because of 410. That was just who they were. You know, but yes, this is a class that is, you know, as long as you stick with it, falling off the bottom isn't going to happen. And if you push it, you will score very highly indeed. It's very friendly to your credit weighted me.
Right, I see you made me the bad cop and there's bad cop, good cop. Because I mean, of course, Connor's saying it right, but we try to balance the courseworks a little bit more now. So it's not the case that the first one is necessarily easier than the others anymore. And I guess they're also, the courseworks are also designed so that it should be hard to get 100%, right? But like Connor said, definitely, if you put the work in, you should have no problem passing this class. I mean, we're here to have fun, but you might have to put in a lot of work to get a really high score. And if you want to do that, then we're very happy to help you, of course. Okay, so should we get started on the more content-rich part of the lecture, which is introducing the programming language Agda that we're going to use in this class. How many of you had a look to see what Agda is possibly could be? Yeah. Okay, I mean, if you haven't, no problem. How many of you remember Haskell? No? Okay, you should remember it from 2 years ago. Yes.
Oh, can I do a student exchange here? So I didn't take the process here.
Right. So Agda in many ways is similar to Haskell, but it's better. So let's see. So here's some. Everything you've seen so far has been in a comment. So comments start with 2 dashes and go to the end of the line. Unless they are multi-line comments, which just like in Haskell, start with a curly brace and then a dash, and then anything until the closing dash and curly braces in the comment. And you see that this is in the funny editor Emacs. And the reason it's in Emacs, and will help you set things up in Emacs, is that you get quite a lot of support from the editor compared to if you program in some other language. So, for example, I can load a file if I press Control-C, Control-L, and if I do that, then it looks like not much has happened because I haven't filled in much else in this file yet. But if we start actually programming it, we'll see what it will do for us. So I thought here as the first example, let's see if we can write the const function, which takes 2 arguments and returns the first one. So this is a functional language. We're going to write a lot of functions. So I'll write this function by saying the name of it. Then I have a colon, and then I give the type of the function. So compared to Haskell, where we had a double colon for the type, in this language, we only have a single colon. Because we're going to write types all the time. So we're saving a lot of colons by just writing 1 instead of 2.
The same is even true of Haskell.
Right.
They did the experiment of what happens to the Haskell code base package, right? The entire kind of public shared repo of Haskell code. If you use 1 colon for typing and 2 colons for list cons, and it gets 10% smaller.
So here we do it right from the beginning.
Yes.
Okay, so I thought I just wanted to write this function. So it takes an A and a B, and it's going to return an A, right? That you might remember from Haskell. Yeah, yes, that's a very simple first thing. So one thing to note is that in Haskell, I would just write it like this, right? Well, with a double colon. I would probably use lowercase letters for these types. But there's a convention in Agda that types are large and scary things. So we usually use uppercase letters for types. And the other thing that's different is because types are more expressive in Agda, I can't just assume that anything that I haven't explicitly introduced is a type, because it could be other things. So I have to explicitly say what these A and B are. So I do that by saying A is a type, and type is spelled set in Agda, which is also a bit unfortunate. So when you see set, think type. And I want to say that B is a set, right? So this says take a set A, take a set B, take something of type A, take something of type B, and return something of type A. Okay, so then in Haskell, I would now have to write this function just from my head straight into the computer, right? But in Agda, I can get a little bit of help from the computer. So rather than doing this all at once, I can leave a question mark for the rest of the program that I haven't written yet. And now if I load the file, Control-C, Control-L, then Agda is going to tell me what I still need to do. So here I have my first goal to fill in, goal 0. And we see down here is a bit small. Sure, we can make it bigger. This is what I need to give something of type of here in order to fill this hole. So you see that I have to take 2 arguments A, B, and then 2 more arguments like this.
Could you move with it, so you have to define the set in a second? Could you write how it's down there, A, B in a second?
Right, yeah, so that's a good point. So here I've carefully written first argument, second argument, etc. But because these 2 arguments have the same type, I can just introduce them in one group like this. And it means, well, let's take it slowly. So first of all, I don't need to have an arrow between different arguments. I just need to have the last one, so I can remove that one. And
Yes,
then
when they're explicitly named like that.
When they are named like this. And now I have 2 things of the same type, so I can just put them in the same name like this. So
Yeah.
A is a set and B is a set.
So these 2 arrows are necessary.
Right, because
It's like
it wouldn't
all
really,
the remaining arrows are necessary.
it wouldn't really make sense to say it like this.
Yes.
Right. So looks like an application. Yeah, so I can introduce all of these like this. Okay, I reload. And I see I have the same goal. Okay, and now I'm defining a function. So I can start introducing arguments here on the left, right? I'm going to call my first argument A, my second B. And now if I reload again, Control C, Control L, see that my goal has changed, right? Now it's A to B to A. And I can put the cursor in the goal and I can ask for the goal type and context. That's Control C, Control comma. You see then I get the goal here. And I also get the type of all the things that I have available. So introduce the A and the B on the left, which means I have them available. And here Agda tells me what the types of them are. So it's not very hard to see this time, but sometimes this can be really helpful. Okay, so now I could introduce more things here on the left. A little a of type A, and I reload. And if I now do Control C, Control comma again, see that I now have a little a available to me, right, of type A.
Does it remove that little a is type A because that was the third thing in the list?
Yes, because I'm supposed to give a function of this type, which means that this argument here must have this type. Yeah. Okay, so now I could introduce the little b on the left as well, but I could also do this with a lambda, which you might remember from Haskell. So I can say lambda b goes to, okay, and then here I should give something, but maybe I don't know this quite yet, so I can always put another question mark. And then if I do Control C, Control space, then that fills in the hole with the thing I had there, right? So we see that the question mark turned into a new hole, and if I reload, then I can see what I have here, and now I see I have a little b of type B available to me as well, right? So I build this up step by step. I don't have to be so clever and think of the whole program at once, right? Okay, so now here I have to produce something of type A, and I have a little a of type A available, so probably that's the one I should give back here, right? So I type that into hole, and I do Control C, Control space to give it. And then you see that the goal disappeared, and it says down here, all done. So that means I've filled all the goals that I wanted. Just in case, I like to reload to make sure that there's no leftover state or anything like that. Right, so in simple examples like this, when there's only one A in A available, then we could also say, okay, maybe Agda is clever enough to figure this out yourselves. If you do Control C, Control A for auto, Agda is going to go and look for a solution for you. And I think this is going to work also for this whole thing here. Okay, so it found a solution for us, and it's the same as the one we had, but it looks a little bit different. So first of all, Agda likes to use the Unicode lambdas. You can get them by doing \lambda. And it looks a bit nicer, but it's harder to type. Or capital G for Greek, L for lambda. It's not a way to do it. Or you can do \\, to just get an ASCII lambda if you prefer. And secondly, Agda figured out that this B argument we had before is not actually used, right? So just put in an underscore for the name of that, which means when it's an argument, it means I'm not going to use it, so you can't refer to it, right? But again, that means the same as the B, it's just not used. Yeah. Okay, so one more thing I wanted to talk about here was that these A and B's here, they don't really matter here for the right-hand side, right? And it's a bit annoying that you always have to introduce these types explicitly. So Agda has a mechanism for inferring certain arguments for you when they are determined by everything else. So if I change these brackets here to curly braces, that means that these are so-called implicit arguments. These are arguments that Agda are going to find out for us. That means we don't have to introduce them here on the left. And whereas if we look here in the goal, we see that we still have the A and B available. They still make sense. They're just not introduced explicitly here, right? So typically when we introduce type arguments, these are things that will just be automatically introduced by Haskell. We do it in an implicit way, so we don't have to mention them, and we can pretend that it looks like a Haskell program again. But it also applies to other arguments. I think we will see that soon enough. Okay, let's put this in again. This is also Unicode arrow, right? So it means the same thing as this. And if you want to do it, it's \arrow or \2. No, because that gives you that. So if you start typing \, you can see down here at the bottom all the things you can continue with. So for example, if I start typing right arrow as a word, then you do get the whole thing. You can ask Connor what he thinks about Unicode. Right. Okay, so Connor, do you want to talk about lists for a bit?
Yeah, in a moment. I was just going to say one thing that has not been explicitly mentioned is that Fred is putting an awful lot of spaces between things. So it's actually a consequence of the Unicode idea. It's that trying to figure out which things count as punctuation marks and which things count as letters in Unicode with a whole alphabet of aubergines and what have you is too hard. So with almost no exceptions, the Agda designers decided that, sod it, just put spaces between things. So there are very few exceptions to that, and round brackets and curly braces are pretty much the exceptions. Otherwise, put spaces between things. It's that simple, but it's the sort of thing that easily gets forgotten. So if yes, so can I use your keyboard? Click on things. Yeah, so if I do that and reload, all sorts of horrible things happen. Okay. Yeah, that's so. What else to say? Agda has no capitalization conventions in terms of enforced by the language. So Fred's choice to use capitals for the types there, that's just good style, but it's not compulsory. Okay, and the other thing I guess I'd say about the curly braces is that that's Fred's instruction to Agda. Please try and figure out these two things whenever I use const. And usually Agda will be able to figure them out, but Agda isn't. They can't make any promises always to figure them out. So that's the way around that is that this is a request from Fred for the machine to do some of the work some of the time. And there is a manual override, which we will get to at some stage. Whereas the Haskell position is that some stuff like type variables has to be figured out by the machine, whether you like it or not. And other stuff has to be explicit, whether you like it or not. And those choices are heavily nailed down in Haskell, and they're under your control in Agda, which may or may not be a good thing. Sure.
So you did it to Lambda. You also got it const AB equal rank.
Sure.
Yes.
Okay, so
Yeah.
currying is fine.
Yes.
And anything you see here after a lambda, you could always put on the left-hand side and vice versa.
Yeah. Yeah. So many ways to skin that cat. But let us get our hands on some data. So a lot of introductory work in Haskell is spent fooling around with lists. So let's fool around with lists just to see what looks similar, what looks different. Okay, so let's declare. They come in these things usually arrive from a library, but I'll build them explicitly. I'm going to declare a type of lists parameterized by a type of elements. Okay, so what do we have so far? First of all, in Haskell, there would be some square brackets here. I'm just going to use the word list with a capital L to suggest that I'm building a type. And then here, I'm saying that there's one parameter for lists, which I'm choosing to name X. And I'm saying X is a set, and correspondingly the whole thing, list of X. So what this says, whenever X is a set, list X is a set. Okay. And then in order to explain how to make a data type, I have to explain how to make the data in the type. So in Haskell, you would write an equal sign at this point, and something like that. In Agda, you directly give the types of the constructors. So let's do that. You'll notice here's a where, which is a lot like where in Haskell. It produces an indented block. So when I'm going to give the constructors for lists, I say where, and then my declarations of the constructors are indented from the declaration of the data type as a whole.
That's single tab.
Sorry?
Single tab.
Any non-zero white space,
Yeah.
as long as you're consistent about it.
Yeah.
Yes.
It's best if you avoid tabs.
Yes.
because
So
using
the habit of a lifetime is to use 2 spaces, but that's not compulsory. So first of all, anyway, I'm going to say that there is such a thing as an empty list, and I'm going to call it open square bracket, close square bracket, which I might pronounce nil. Right. And there's absolutely nothing special about bracket character or about square brackets. They're just ordinary characters, the same as Q. I happen to have chosen a 2 character identifier, which might look a bit like an empty list, but it's just a name. Right.
I see there's some things you can't use, so you could put lambda as well.
I couldn't put, yeah, there are very few reserved characters, but lambda is one of them. Okay, so here I'm saying that nil is a list of X. So one thing I'm pointing out here is the things which live left of this colon in the declaration of the type as a whole are in scope for the whole declaration. So if I put, well, actually, I can load the file already. I can say that and it's happy that, so it's saying all done. It's not complaining at me at all. I could, and yeah. What's more, I don't get to choose anything other than X here. All right. If I put something like set there, oops, what have I done?
good question. Taking a screenshot.
Excellent. Okay, I'm trying to save the file. Right, then it says, oh, it's complaining that that's not the error I wanted. Let me make a different mistake. It's quite difficult to make a different mistake, actually. Well, maybe tell you what I'll do. I'll say for all Y, oh, that one. Yeah, I guess I can do list X. Oh, I keep doing that.
Or is it because you're not used to the control?
I'm not used to where your control key is. I think I'll get the hang of it eventually by about Christmas. Right, so what it's saying is, hang on a minute, list X isn't X. You're supposed to be telling me how to make a list X and no other damn thing.
Sorry, when you go back a little bit, when you load, is that you compiling or?
Well, type checking.
Type check.
So it's perfectly happy to let you work in very small steps, and it's an extremely sensible idea to ask Agda its opinion of your stuff early and often. Okay. So we will want to also have, I mean, we've got a way of making empty lists, but we better have a way of putting elements into lists. In Haskell, that was cons, and it was written with 1 colon. We shall habitually use 2 for that. So let me just do it and then talk about it, and forget to say half the things I should say, at which point Fred will say the other half. So what is the type of cons? It takes an element in X, a head element, and it takes the whole rest of the list, the tail, which is a list of X's, and that gives us a list of X's. So we're saying, here is the little Lego kit that you can use to make lists. You've got nil, and you've got conses, and all the lists are built from those pieces.
As those underscores just like
Going there in a moment.
okay.
Right, because so we would like cons to be an infix operator. So the way you name an infix operator in Agda is that you put underscores as parts of the name where you want the stuff to go. So underscore double colon underscore is the name of an infix operator that takes stuff before the double colon and stuff after the double colon. So you're really just drawing the picture of what the thing's going to look like in the name of the operator. And you can do all sorts of other stuff like that. You can do if underscore then underscore else underscore, and stuff like that. You just build operator shapes and confuse the hell out of anyone trying to read your code. So try to use this with good taste. But infix operators, fine.
Can I ask a very simple question?
Yes.
First one, defining function, second one, defining.
This is the head of the new list?
No, is it the data list thing? Is the whole of that is defining type?
Yes.
Yes.
The whole of the above defining.
Right. So this is defining, yes, this is defining a whole new function, declaration, definition.
Yeah.
This is the declaration of a data type where I introduce a type constructor, and Agda colors those in blue. These are the data constructors that build the data. And you see this keyword data, you know that you're saying, I'm going to introduce this closed notion of data, and I'm going to enumerate all and exactly the ways of building the data that make up lists. So there ain't no lists other than the lists that are made with nil and cons. No one can make up any more spurious sorts of lists. You got nils and conses, and what's more, you can only plug them together in finitely many ways.
And these lists can't have different types of.
Yeah, and they're uniform with respect to the element type that you supply as a parameter.
That's what you see with the type of cons here, right? It takes a list of X for the tail, and it gives you back a list of X. So if this was a list of something else, then it wouldn't be the right type.
Yes.
I will have functions into sets, which is another way we can use type. But then that way we can actually see the objects.
Yes.
Yeah.
So with the data declaration, you're giving some new constructors and you're making new type out of those. If you already have some types, you can put those together and interestingly just that on the function.
Yes.
We'll get to that.
We'll get to that, but yeah, if you think about it's like the distinction between data declarations in Haskell, where you were saying here was a completely new type that we didn't imagine before, versus when you make a type declaration in Haskell, where you're saying, oh, I'm just making an abbreviation for some stuff that was already there. And Agda doesn't need type declarations because as far as Agda is concerned, that stuff's just programming, right? You know, it's just a definition. It's the same as any other damn definition. Anyway, it's 2:15. Let's concatenate lists. Right. So I'm going to write a function to put, to glue one list onto the front of another. So let's see. Do we care what sort of elements are in the lists that we want to concatenate?
To be like the same, like you have an X,
Yeah, if we're going to combine two lists into one, we better be uniform across the inputs and the output as to what element type we're using. But apart from that, we don't care. So I'm going to be bold and suggest that Agda should most of the time be able to figure out the element type. And then I want to take a list of X's in and another list of X's in, and I want to give back a list of X's. That seem like a reasonable type? So now I'm going to say append X's, Y's equals question mark, right? So this is very typical. Don't try harder. Just name the inputs, equals question mark, load the file, game on, right? That's the thing. Agda is a computer game. Control-C, Control, comma, where am I in the game? Right. There's this type of elements that's not in scope. I've got two lists. I'm asked for a list. How am I going to go? The usual game here, right? The functional programming game is about saying what the output is when you know what the input is. It's all about being, not about doing. And in order to figure out what things need to be, you need to look and see what things are. So the question is, can we yet see enough about the inputs to say what the output ought to be? We have the input, the lists we know how to make at the moment are the empty list. We can always make that. And we know how to make Y's, and we know how to make X's. We don't know how to use cons here because we don't know any elements. Which is always wonderful. That's really great that this element type is arbitrary and not under our control, because it means that we can't accidentally make some up. We're really quite constrained, right? We don't want to give back nil or X's or Y's as the output. So we're going to have to get more information about the input. Okay. So this is the wonderful thing. I always want to be able to do this directly with some violence. I always just want to karate chop pattern variables on the screen.
Wow.
But
we can make that happen.
Yes. Okay, so we need to decide which of these two things we're going to look at. And I think, given that we build up lists from the front, it's probably a good idea to look at the first list. So let's so what it's taking now, it's taking this directly from the declaration. So we said, here are the two ways to make lists, and the lists are made only in these two ways. So when I say we need to look at the first list, it calculates what are the ways that first list could have been made. That was Control-C, Control-C.
If we go back a bit.
Yes. That was the trouble. It was
so, right. So I put the cursor in the goal, and then I press Control-C, Control-C. And down here at the bottom, it's asking me, which variable do you want to case on? C for case, right? And
Yeah.
then I typed in X's while Connie distracted you over there. And I pressed enter and it split on X's.
Okay, so now we've got two problems, but hopefully two easier problems. What do we do with nil, and what do we do with x cons x's? And now we have to think, well, have we seen enough to figure out how to build the output? So can we say what you get when you can append nil to y's? What should that be?
Ones.
Yeah, so we can just give y's. Cool. And now, have we seen enough to say what this is? Well, we know that the first element of the first list is x. So have we enough to say what the first element of the output is? Yes. Right. We can get as far as x cons something. So cool. We can just give that. Work it a little bit at a time, right? So, you know, just step, step, step. And then how do we, if we want to build up the rest of the output, well, we can make a recursive call to append, giving a smaller first input. All right, so this is going to work because the data promise is that data are built up using the constructors by finite amounts of work. Correspondingly, that means as we peel off one element at a time, we're bound to reach nil eventually. So there's no danger that this definition will ever go into an infinite loop, because we're guaranteed that lists are finite. That's another big difference from Haskell, where lists are finite or infinite at liberty. And we sometimes pretend dishonestly that they're all finite. Like, we have functions like length, and you were basically just told, like, you know, you better not run that length function on a list that happens to be infinite. You know, this is not the way we play this game here. There are such things as infinite lists in Agda, and I suppose we'll arrive at them sooner or later. There are co-lists, and there are things which are definitely infinite. So streams, these are all different things, and we can tell them apart. The thing about Agda is it's about telling the truth. What we're going to try and teach you is the unreasonable effectiveness of honesty.
Right. Should we show what happens if you write something non-terminating, or should we save that for Thursday?
Right. Well, we could. Yeah. Why not? Yeah. Why not make that append x cons x's?
So here we are saying that we're claiming that this thing is defined to be itself and something constant on top of it, right?
Yes.
So if you think about running this, then it would just keep consing x and never terminate, right? So if I now load this, then Agda is going to shout at us in red, right, saying termination checking failed for this function, and it tells you exactly what the problematic call is.
Yeah.
It's not always so easy to see exactly what the problem is, but if it's red, then it means there is a problem. Right? So Agda is only happy if things actually terminate.
How does it prove that?
Well, it's quite an interesting bit of science, but yeah, Agda has a sort of paranoid, conservative, overcompensating non-solution to the halting problem. It will occasionally frustrate you by not accepting perfectly sensible definitions, but it is absolutely, when we put it, it's checking to see whether it can find an explanation in terms of inputs getting smaller.
Yeah.
So it's like y's is no smaller than y's, and x cons x's is no smaller than x cons x's. That's not going to work. Whereas here it says, okay, things don't get smaller in the second argument position, but they do get smaller in the first argument position. So this is going to be fine. So it's really making use of the structure of the data to say, yeah, this is solving a bona fide sub-problem. So, you know, that's fine. That's going to work.
And the other way you could try to trick Agda would be to not give the base case, for example, right?
So
It might
yeah.
look good, but you don't know what to do when you reach the empty list and you're still in trouble. So if I comment this out, then we see that we also get a warning or an error about incomplete pattern matching.
Yeah. So when you say, so this is a big difference from Haskell. When you say, I'm going to give a function, then you will be explaining why it is defined on all possible inputs and why it will definitely produce an output. I mean, it's got to cover and it's got to terminate. So I think there's a classic joke which we should tell, even though we've got 2 prime ministers under the bridge since then. The type of Brexit is that for all A in set, you can just have any element. You can have an element of whatever type you want. Right. Anything you want, you can have. That's the type of Brexit. And the definition, thanks to Theresa May, is that Brexit means Brexit. And Agda says, oh, problematic calls Brexit. So whereas Haskell will let you make this definition and then only give you problems when you try and use it, Agda will notice that it's a very bad idea. Okay, so looks like a good time to stop.
Yes.